We now come to the final section in Unit 8. Section 8.8, which deals with solving radical equations. Equations that involve root symbols. I'm going to do 3 problems for you. If you'd like to pause the video at any time and solve them yourself and see if you get the correct answer, please do. Here's problem number 1. 5 times 4x plus 3 to the 1/3 power is equal to 15. Well, first steps, just like what we have been doing with log functions and exponentials. Step number 1, get rid of all numbers outside the root symbol. Well, I got one number that's outside the root symbol. Remember, 1/3, I could rewrite this as 5 times the 3rd root of 4x plus 3 is equal to 15. Remember, that's what 1/3 means. We just learned that. So, the number that's outside the root symbol would be the 5. I got to divide both sides by 5 since that's a times sign. So these cancel out, and I'm going to get the cube root of 4x plus 3 is equal to 3. All right, now, since I've gotten rid of all the numbers outside the radical symbol, all that's left is what's on the inside. To get rid of the cube root, I need to raise to that power, whatever that root number is, that's the power that I have to do to both sides, because the cube root and cubing cancel out. That's like 1/3 times 3, which is the power of 1. Pretend I times that by 3. Those 3's will cancel. Power of 1. Which will leave me what's on the inside of the square root, or the cube root sign only. 4x plus 3 is equal to 3 cubed. That's 27. Oh, wow, nice problem. Now I can solve this. Minus 3 to both sides. I get 4x equals 24. And divide by 4, and I get x equals 6. So step 2, raise both sides to the power of the radical symbol. And then now that I've finally got my answer, you need to check for extraneous solutions, because sometimes you're going to get numbers that don't work. So I got to check for extraneous solutions. I got to check if this 6 works. It may not work. Well, let's see. If I put 6 in for x, now I'm going to write this over here so we can see this more clear. 4 times 6 plus 3 under the square root. Well, 4 times 6 is 24 plus 3 makes 27, which makes the cube root of 27. We all know the cube root of 27 is 3. So 5 times 3, yep, that does. It equals 15, which is what we wanted. So therefore, this number checks, and that is the answer to the problem. All right, example number 2. X equals the square root of x plus 12. All right, well, first of all, here's the square root symbol. Is there anything on the outside out there that we got to get rid of? Well, obviously the answer to that is no. So therefore, since it is square root, I'm going to put both sides in parentheses and square both sides. All right, well, the left side becomes x squared, which is equal to the right side. The square and the square root will cancel out, leaving me x plus 12. Oh, pretty simple. I got a squared problem. That means I got to make it equal to 0. So I'm going to minus x and minus 12 from both sides, make it equal to 0. And now I got a factor. That becomes x minus 4 times x plus 3 equals 0. And we all know that piece gives you an answer of x equals 4. And this piece gives you an answer of x equals negative 3. Well, now I got to test it. So I'm going to rewrite my problem over. X equals the square root of x plus 12. Let's see, does this work? Well, let's try 4. 4 equals the square root of 4 plus 12. Well, the square root of 4 plus 12 is the square root of 16, which equals 4. Good, so that works. Well, let's try the other one now. Negative 3. I'm going to put negative 3 where the x's are. The square root of negative 3 plus 12. So this equals the square root of 9, which is equal to positive 3. Uh-oh, that doesn't work. That doesn't work, so therefore this is an extraneous solution. That's bogus. Therefore, x equals 4 is your final answer. One more. I'm going to change this problem slightly. We're going to write this as 2x minus 4 equals 4x plus 8 minus 4. All right, well, here we go, people. Let's give this a try. Again, first thing I look at is the square root part. All right, and there is this number on the outside, so I need to get rid of that first by adding 4 to each side. Well, those will cancel and those will cancel, leaving me 2x equals the square root of 4x plus 8. All right, I'm down to the square root. It's a power of 2, so therefore I'm going to square both sides. Well, this side is 2x times 2x, which is 4x squared, which is equal to this side over here, which is what's left inside the square root symbol. So I get 4x squared equals 4x plus 8. All right, well, got to make that equal to 0. 4x squared minus 4x minus 8 equals 0. And I'm going to factor out the common term, which is a 4. So I get x squared minus x minus 2 equals 0. And continuing to factor, this becomes x minus 2, x plus 1 equals 0. So what are our potential solutions? The 4 doesn't matter because 4 cannot equal 0. X minus 2 can equal 0, and therefore that will give us an answer of x equals 2. And x plus 1 will give me an answer of x equals negative 1. So again, I got to check for some extraneous solutions. Go back to my original problem. 2x minus 4 equals the square root of 4x plus 8 minus 4. And we need to do some testing. So let's try 2. If I put 2 where the x's are, what do we get? Well, this becomes 2 times 2, which is 4, minus 4, I get 0, equals, over here I get the square root of 4 times 2, which is 8 plus 8, which is 16 minus 4. Square root of 16 is 4 minus 4. Hey, that equals 0. So x equals 2 is a solution. How about negative 1? Let's try negative 1. If I put negative 1, 2 times negative 1 minus 4, is that equal to the square root of 4 times negative 1 plus 8, and then the minus 4 way out there? All right, well, 2 times negative 1 is negative 2 minus 4 is negative 6. Now, how about on the other side? We get the square root of this part in here becomes 4 minus 4. So negative 6 equals the square root of 4 is 2 minus 4. Uh-oh, that equals negative 2. That does not equal negative 6. Therefore, x equals negative 1 is an extraneous solution. Extraneous solution. And therefore, my answer is x equals 2. And that, people, is how you solve radical equations.